For each integer n greater than or equal to 2, let S sub n be the sum of all products j, k, where j and k are integers and 1 is less than or equal to j, j is less than k, and k is less than or equal to n. What is the sum of the 10 least values of n such that S sub n is divisible by 3? We're going to start with just looking at what S sub 2 is equal to. So all possibilities there, j and k are integers. So in this case, smallest j would be 1, and k would be equal to 2. And those are the only pairs that we could do because k has to be less than or equal to n, which is 2 in this case. So S sub 2 is 1 times 2, which is 2. Now looking at S sub 3. So in this case, we could have, again, j equal to 1, k equal to 2. But we could also have, should be a lowercase j, j equal to 1, k equal to 3. We could have j equal to 2, k equal to 3. And so that sum would be 1 times 2 plus 1 times 3 plus 2 times 3. And one more, looking at S sub 4, what that is that would be 1 times 2 plus 1 times 3 plus 1 times 4 plus 2 times 3 plus 2 times 4 plus 3 times 4. And so writing this another way, this is 1 times 2 plus 3 times 1 plus 2. And this is equal to 1 times 2 plus 3 times 1 plus 2 plus 4 times 1 plus 2 plus 3. And we can generalize this to 1 times 2 is just S sub 2. So this is S sub 2 plus 3 times 1 plus 2. And this is all S sub 3. So this is S sub 3 plus 4 times 1 plus 2 plus 3. And so the pattern is going to continue the same way. So generalizing, we can say that S sub n has to be equal to S sub n minus 1 plus n times 1 plus 2 all the way to n minus 1. And we can write this, the arithmetic sum is S sub n minus 1 plus, this is going to be n times 1 plus n minus 1 times n minus 1 all over 2. And this is really just equal to n. So simplifying this, we have S sub n minus 1 plus n times n is n squared times n minus 1 over 2. So this is a generalized formula for S sub n. Now looking at this divisibility by 3, we'll go through 3 different cases. So when n is equal to 0 mod 3, it's going to be true that this term is also equal to 0 mod 3. And so that's because 0 squared is 0. Next, if n is equal to 1 mod 3, then we have this is also equal to 0 mod 3 because you plug a 1 in here, that evaluates to 0. And lastly, we have n equal to 2 mod 3. And then this is going to evaluate to, you plug 2 in here, this is 1, 2 squared. This would evaluate to 2 mod 3. And so in each of these cases, we're going to see what S sub 2, S sub 3, S sub 4 looks like and see if we can find a pattern. So when n is equal to 2, that first case, we already found out that S sub 2 is going to be equal to 2 mod 3. So not divisible by 3. Look at n equal to 3. Well, S sub 3 is equal to whatever S sub 2 is, so 2. And then we're going to add whatever the value this is. So that would mean that n is equal to 0 mod 3. So we're adding a 0. And so equal to 2 again, not divisible by 3. N equal to 4. S sub 4 S sub 4 is equal to S sub 3, which is 2, and then that would be equal to 1 mod 3. So again, this term is 0. So again, not divisible by 3. So now n equals 5. We're just going until we notice a pattern here. S sub 5 is equal to the 2, but now S sub 5 is 2 mod 3. So we're going to add a 2. 2 plus 2 mod 3, that's 1. So again, not divisible by 3. N equal to 6. S sub 6 equal to 2. Or rather, S, since this is 1, it's not 2, it's 1. And then this term is going to be 0. So we get 1 again. N equal to 7. S sub 7 equal to 1 plus 0 mod 3. Again, 1. Now when n is equal to 8, that's equal to 1, which is S plus 7, but now plus 2 mod 3. So this is 0 mod 3. And that pattern, that's going to be true for S sub 9 is equal to 0 mod 3. And S sub 10 equal to 0 mod 3. And then when you get down to S sub 11, that's going to be equal to 0 plus 2 mod 3, because this term would be 2 when we have n equal to 11. And so this is not divisible by 3. These are divisible by 3. This is not. And the pattern is going to continue. As you can see, we can see it goes not divisible by 3, this chunk of 3, not divisible by 3, that chunk of 3, and then there's a chunk of 3 that is, and then the cycle just continues with these values. So values of, this is asking for the sum of the 10 least values of n such that s sub n is divisible by 3. Well, 3 of them are 8 plus 9 plus 10. And then it's true that every 7th term, because we went 7 terms, 1, 2, 3, 4, 5, 6, 7, until we got here. So it'll be another 7 terms from the 10th until we get n values of n where s sub n is divisible by 3. So those other values would be 7 plus 10 is, so 17, 18, 19, plus, and then 7 more than 19 is 26, 27, 28, and then plus 7 more than 28 is 35. So these are the least values of n. We add all these up. Comes out to 27 plus 54 plus 81 plus 35. That sum is 197, which is our answer. So the answer is choice B.